Hey everyone, welcome back to the Rogue Coder. In this video, we'll be talking about implementation of object-oriented programming in Python, how do we write classes, objects, and other basic stuff. So let's get started. If you haven't already watched the previous video where we discussed the basics of object-oriented programming, and maybe if you don't know object-oriented programming or haven't looked at it in a long while, I'd suggest you go look to my previous video over here. The link will be up here and in the description. And if you already have, then let's get started with this. So here I have opened up Pycharm, and that's where we'll be working for this video. So whenever you want to create a class, that's what we do in object-oriented programming. So what do you think we should do first? I mean, of course, create class, but yeah, let's start with that. So I'll be writing a class here that says, okay, our class Earth. Let's just keep it class Earth for now. And let's say this class Earth of ours has a function. But before we go anywhere, like we discussed in a previous video, that every class needs to have a special method called the constructor method, and in Python it's written as the init method, and there needs to be a double underscore before and after the init word. That's how it's written in Python. So once you've done that, let's just put two variables in here. So let's just put self dot population equals population. I'll have to pass the population here in the arguments. I'll just explain what's happening in just a sec, but let's write this for now. And if I give here an year saying how long is a year on the Earth, I can say self.year is year. I'm just doing this so that I don't have to go through the well work done example that almost everybody uses of a dog, an animal, or a vehicle and a car. I just wanted to go with something different. So it's just that, nothing much. And then let's just okay, let's not do that. So we have a class, we have defined the class, we made a class called Earth, we made its init method, and what this init method does is whenever we initialize this class, it will take two variables, population and year, and it'll just store them like that. It doesn't do anything much now. And as we discussed last time, self is a mandatory keyword when it comes to object-oriented programming in Python. It just references the current object that you will be working on. You need to write it whenever you are referencing any variables inside that class. So if we want to create an object of this class Earth now, an instance if we may, we write, let's say, I'll just write planet Earth equals Earth, and if I now as soon as I hit parentheses over here, it shows me that I need to enter population over here. That's because we have provided those arguments in the init method. So let's say we have a population of 20,000 people. This is a magical Earth, and the year on this Earth will be, say, of 100 days, or maybe that should not be the year. It doesn't mind. You can think of it as whatever you want, whether it takes 100 days or it means 100 years. It depends on you. So once we've done that, what we can do now is try to print what planet Earth actually shows us. And if we run this program, it will show us that planet Earth is an instantiation of the Earth class. That's what it shows us over here. Down here in the terminal, it shows us that this function was called in the main function of the Python file, and the object was the earth type. That's what we defined our class to be. We defined it to be earth, and it just shows the memory where that object is stored in our memory. Now we defined an instance of the class. Now what we can do is we can print out its variables. We can say planet Earth dot population, because that's what we defined it. And if we print this out, it shows us 20,000. Or if we want, we could go ahead and just say year, and if we run this, it shows us 100, because that means we're able to access the variables or the attributes of our class. Once that's done, you are done with the basics of object-oriented programming. Oh no, we're not done with the video yet. Just why do you want to run away from my videos? They're good. So let's define another method in our class that says show status. This will just show the status of the Earth that we've created. This magical Earth has 20,000 population and it's still 100 years. Never mind. So let's just put in a couple of print statements in here saying, and yeah, you always have to include self, like we discussed previously. Self needs to be in all of the methods that you define. So let's just say the population is, and we'll just say self.population. So as you can see, whenever we are referencing the variables outside of the init, we still call them by self.population. And if we say print the duration of the year is self.year, and I'll just say days. This must be a magical Earth, right? Every 100 days you have summer, winter, and God knows what else. So if we try to run this now, but before we run it, we actually have to call our new methods, right? So let's just say planet Earth, that's the object we created here, and we'll call the show status method on it. We don't need to pass self when we are calling the actual method. The self needs to be passed when you're writing the code in the implementation of it, not in calling of the method. So if we run it, we get this. The population is 20,000. The duration of the year is 100 days. Nicely done. So whenever you're writing self.year and that part gets called over here, self in this line would refer to this object, planet Earth. Now people who already are accustomed to Java, they may recognize this word self as analogous to the this keyword in Java, and I would say they're not exactly the same, but in this context you can take them to be similar, if not a lot similar. This actually clears up a lot of the basics of object-oriented programming than you'd expect, but we still have a few things to go, such as what the other last things are that we discussed in our previous video. Things such as encapsulation, inheritance, and polymorphism. So to do that, let's just create another class over here and call that class up. Let's just go one line down here. Let's just call it the class planet. Okay, imagine we're creating a big game and we are making the solar system. So we first created the object for the planet, and then inside that we'll call it, just a sec, you'll hold on, you'll understand what I'm doing. Let's just call a planet, and we will first define the init method, because that's what we need to do every time when we create a class. And let's just ask it to have a method that says parent star. Okay, and now we can say self.star is parent star. We have that. And then we can also define a function here that says def, hold on, let's just go to the next line, def show star self. You don't need to say here anything else, and you can just say print the parent star is of this planet is, and you can say star. Exactly, you can't say star, you need to say self dot star. That's the name that you've given to that instance variable. No. And yeah, by the way, these variables that are in classes, they are also called as instance variables. Right? Instance variables. Yeah, bad spelling. So now if you try to relate these two classes, you will notice that the planet Earth class is a higher form in a hierarchy than Earth. I mean, Earth is a type of planet. So what you can do is you can use inheritance. You can say that, okay, every property that is present in planet will be by default and by definition present in planet Earth. So what you can do is say planet, and that means you've inherited it. That means you have called it. And now what happens is an amazing thing. See, Python code tells you that you have tried to define init here, and you have also tried to define init here. So what gives? Like, which init should I use? Should I use the init of planet or should I use the init of Earth? Well, when you call this, let's see what happens. I'll just put a print statement here that says in planet class, and we shall see if it gets printed or not. And now if I run this, it doesn't get printed. I still had an object here from planet Earth, but an object Earth did inherit from planet over here, but I still don't see any of that print statement. Why? Because when we pass a class as the parent of a child class here, the class planet would be called a parent class because it's higher up in the hierarchy, and the class Earth would be called a child class because that's lower in the hierarchy. So whenever the init method gets called, the init method of class Earth gets called, not planet. If you want to call the method of the init method of class planet, what you need to do is in the class Earth's init method, you need to write super and then provide the method that you'd like to call. Okay, but remember now, when you are calling init, the init method of class planet requires a parameter, and you need to provide that. So let's just say sun for now and see how it works. Okay, the line does get printed. It gets printed in planet class. That means our code does reach here. And with that, we'll put an end to this video. And in the next video, the one after this, we will be discussing about what polymorphism is and a little bit more about inheritance and how you can implement encapsulation as well, and a couple of other things, and hopefully we'll take this series much more farther ahead. So thank you for watching and stay tuned for the next updates.